Hi guys, this is Ananjan from iWork Club, and this is the first part of our series on ROS2. In this video, we'll just set up the foundations for you as to what is ROS2, how is it better than ROS1, and what is the setup and installation process of ROS2 on your system. And we'll also help you create your first workspace, and we'll get you a rough idea on how the packages work and how to use them using Qualcomm later on in the video. Also, we'll just make sure that by the end of the video you have an idea of how do even robots communicate or how do they even work in the modern world where robots are one of the most stable things human has created. As you might know that ROS stands for Robot Operating System. But is it actually an operating system? Well, not completely. It's like a set of tools and frameworks to help you build robots. For example, you can think it of in a way that it is a common language for robotic software that lets different hardwares and softwares to communicate with each other, like the way our body performs. So, how did we even get here? Like, how did we even reach ROS2? Like, to give you a set of basic ideas about ROS1. So the original ROS was introduced in 2010, and it was basically the most common and open source software for robotics development. It opened doors for different robotic frameworks and basically researching about robots. But over time, the people demanded more things like real-time performance, security, and multi-platform multi-platform support. And this is where ROS2 was introduced to address these issues. What are the key differences from ROS1 of in ROS2? ROS2 introduces a new communication layer known as DDS, which is called Data Distribution Service, which means better and more reliable communication between components. ROS2 supports more than just Linux, and it also works on Windows and Mac OS. You get improved security, much better lifetime support, and a design that's steady for commercial and industrial use. Now you might wonder where ROS2 is exactly used. Well, ROS2 can be found in robotics research labs and even in industry automations, drones, self-driven cars, and medical robots. Basically, if there's a robot, ROS2 could be running somewhere in the background and you might even not realize. Now you might wonder, why do you even have to use ROS2? Why should you care about ROS2 if you're building a robot or an automation project? Modern middleware with DDS, ROS2 offers robust, scalable communication even in distributed systems. Also, I told you about the real-time support which is offered in ROS2. How is it exactly useful to you? Well, this is critical for robots that cannot tolerate delays like robotic arms or automation vehicles. One of the major improvements in ROS2 from ROS1 is the cross-platform support. Whether you are a researcher working on Linux or developer using Windows or Mac OS, ROS2 you have to you can use it on any platform. What are the security enhancements in ROS2? ROS2 provides encryption, and tools to prevent unauthorized access or tampering. What is the what is the active community and industry support? Many robotic companies from startups to giants are adopting ROS2 as it is very modern and creates solutions for a lot of things that were wrong in ROS1. Industries like agriculture, warehouses, and even hospitals are using ROS2. For some example, in agriculture, they can be used for autonomous tractors. In warehouses, they can be used for logistic robots, and in medical, obviously, there are doctor robots or delivery robots. In summary, combining everything that I said, if you want to build robots that are reliable, scalable, and have cross-platform access, you can use ROS2 in the way forward. Alright, let's take a moment to talk about something very important before diving deeper into ROS2. Where can you actually run ROS2? And how do you choose the right version? And what is even distro, like the term everyone talks about? When it comes to operating systems, Ubuntu is by far the most recommended platform for ROS 2. It has the smoothest setup process, the best support, and most of the official tutorials and packages are built with Ubuntu in mind. That's why for the video series I'm using 22.04.5 version of Ubuntu, which is a great match for one of ROS 2's long-term supported versions known as Humble, or in long term it is known as Humble Horse Bill. And now besides Ubuntu, you can install ROS 2 on Windows and Mac OS, but it has limited features and are not recommended. Windows has official support, which makes ROS 2 accessible for industries or workplaces that rely on Windows systems. Mac OS is also supported, but it's very limited as I stated earlier. Some features might not work the same way they do in Linux, and certain packages might not even build. So, if you're starting out, you download Ubuntu with me for the best experience. Now, let's talk about distributions, or in short, distros. These are just different versions of ROS2 released over time, kind of like how Ubuntu has versions like 20.04, 22.04, and so on. We are choosing 22.04 by the way. Each distro has a unique name like Humble, Iron, or Jazzy, and each one is made to work best with a specific version of your operating system. So, how do you choose the right one? You might wonder. Um, First, look at your operating system. Since I'm using Ubuntu 22.04, the best match is Humble, which is a long-term support distro. This means it gets update, bugs fixes, and community support for a lot of years. As far as I know, it's still 2027, so it has a long way to go yet. If you are starting a new project on ROS 2 or just learning new things, you can go with the Humble version as it's more stable, reliable, and widely used. On the other hand, if you're feeling like you want to explore a bit more than your comfort zone, you can always explore more versions like Iron or Jazzy. But keep in mind, they might not have the same level of community support and resources online for learning them, and it might be a bit tougher for you to explore them. And if you're wondering, where do you even find this information? Well, you can check, or you can always check on the official ROS2 distributions page, where they list all the release versions, their compatibility with different operating systems, and how long each version will be supported. There's also a release schedule page where you can see upcoming versions, official end of life dates, and versions that are no longer maintained, for being mostly updated with all the versions of ROS2. So open your browser and go to Ubuntu 22.04 download, and click the second link where it directly takes you to the version we are supposed to download. Now you can download any image. We'll go with the desktop image because it also has a GUI and it doesn't make a difference, but still we'll download this one. Now you can open a new tab and search VirtualBox. You can even select it from the search box or just manually type it. Go to the first link and just download it from here for Windows or your software. We are downloading it because we need to create a virtual machine on which we will run our Ubuntu on. You can either run your Ubuntu on dual boot virtual machine or make a USB drive, but I prefer this one for our use case. So my VirtualBox file downloaded, so I'll just run it, and just this dialog box appears. We'll just accept the terms. I don't think anyone would care about reading the terms. If you care about it, you can definitely read it. From here you just click yes, next. You can select all the options that you want. If you don't want a desktop start shortcut, you can unselect it and stuff. First, we need this VirtualBox to create a virtual machine, as I said, and we'll load our Ubuntu on it, and then we'll download the ROS2 on the Ubuntu, and just click on finish and wait for and you can just skip this part for now. Firstly, wait for your file to download, the Ubuntu one, and then we'll come back to the next step. It is downloaded, click on new, then select any name, select the folder you want to download it in, and then select the file that you just downloaded it. Like you'll find it in the downloads folder if you downloaded it from a browser, and then come to the settings and then just select 4 GB RAM or something, anything you want, and then click on this setting and then select the amount of storage you can allot. You can leave it as it is, then come back to the settings and check this box and click on install. Then you need to click on start and then install Ubuntu, and then when you click on install Ubuntu, wait for a time, and then this is the keyboard layout settings. Just leave it as it is, press on continue, then again press on continue. Wait a second, and again you can just click it, install now, and then you can just continue. It's not a problem, and you just need to wait for some time. And then just select continue, and then just put any username. I'll just put anything random. You can put anything, as it is local, it is not server based, so you can just put anything. I'll just put Aryan ZZZ for example, and then just enter your password. You can enter anything, but as long as you remember it. And after matching the password, click on anything. You can click on login automatically, it doesn't matter. Then click on continue, and then just need to wait for a bit. You just the procedure is almost done to install Ubuntu. You just need to restart whenever the option comes up on the screen. You can wait here for some time, and then afterwards a screen will come like this, and just you need to click on restart now. Before that, just make sure this is unchecked, this option, and just click on restart now, and then it will take some time, and afterwards you'll get this screen. Just enter your password which you kept earlier, and press Ctrl plus Alt plus T. Press Ctrl plus Alt plus T to enter the terminal box and type the following: sudo apt update and sudo apt install curl gn upg lsb release, and then just type y and press enter. Enter your password and wait for some seconds. Afterwards, write the following command: sudo curl slash small s capital L https ://raw.github user content.com without any space, and then /ROS distro /master /ROS.key space -o space /usr/share/keyrings /ROS -archive -keyring.gpg. Press enter. It should run successfully, otherwise there's some issue. Then type echo deb bracket arch is equal to dollar sign, and then round bracket dpkg space hyphen hyphen print hyphen architecture architecture round bracket close space, and then write signed hyphen by is equal to slash usr slash share slash key rings slash ROS hyphen ARCHIVE hyphen keyring dot gpg, and close the round square bracket, and then write space http colon slash slash packages dot ros dot org slash ros2, and then write slash Ubuntu space dollar sign round bracket open lsb underscore release hyphen cs bracket close space main, and then put a line, and then write space sudo space t space slash etc slash apt slash sources dot list dot d slash ros2, and then you just need to write dot list space greater than sign space slash dev slash null. Oh, there's an issue. I think I missed some space here. Okay, so the problem here is, okay, so I missed the space between the release and the hyphen. You need to be careful with spaces, as it will be a lot of pain if you miss any correct spaces. Then write sudo apt update, and then it will be a long process. It will just install all the ROS2, and then we need to write sudo apt install and ROS hyphen humble hyphen desktop hyphen y. This command is for installing ROS2 for complete screen. We can obviously install it for mini screen, but I prefer it for full screen. Then it will run this for a long time because it is just installing ROS2. You just need to wait until it's all done, and afterwards I'll get back to you. After everything is done, make sure to write the following commands. This is for installing the environment. Just write echo space inverted commas source space slash opt slash ROS slash humble slash setup dot bash commas close space greater than sign space, and then this sign slash dot bash rc bash rc, and then press enter, and then write source this sign slash dot bash rc, and once you enter it, just check your installation with ROS2 doctor. If all the checks are passed, then you're good to go and your ROS2 is successfully installed. Let us kick things off by setting up a fresh ROS2 workspace. This is the main hub where you will organize all your robotic packages and code. Write mkdir -p tilde slash my underscore new underscore ROS2 underscore WS slash src. Wait, I'll just type it. Press enter, and then write cd tilde slash my underscore new underscore ros2 underscore ws. Basically go in that directory and then write ls hyphen n. You will get to know about the list of your directory basically, and this is the first workspace created for you of ROS2. Now that our workspace is ready, let us create our first ROS2 package. Think of it as a small robot app or module. We'll use here C++ for example. Firstly go into your directory, write cd src, press enter, then write ros2 pkg create --build -type amend underscore cmake demo underscore cpp underscore pkg, press enter, and then write ls demo underscore cpp underscore pkg, then write cat demo underscore cpp underscore package dot xml. I'll explain you every meaning in a second. And then write cat demo underscore cpp underscore pkg and slash cmakelist.txt. You can write it by simply clicking the arrow up button and just deleting the package.xml and just modify it from there. I'll just type it capital C capital M make capital list.txt. I hope you have been following me. Now I'll explain you all the commands that I just ran. Basically, firstly we went into the src, which has all the new packages which we need to in a workspace. Then when we wrote ros2 pkg create build -type etc., ros2 generates a package named demo underscore cpp underscore pkg using the standard build system. Afterwards, when we used ls demo underscore cpp underscore pkg, we peek inside our inside what is there, and we see important files such as package.xml, and then the like package.xml has like metadata and dependencies, and cmakelist.txt tells ROS how to build the code. Now we'll build what we just created. ROS2 isn't aware of what we just wrote, and it isn't aware of any new code until we build it. So how do we build it? So come to the terminal and come out of your src. You can do it by cd ... and then just write colcon build. It should build the package, and if it is there any problem, you can skip to the end. Now write source install /setup.bash. Basically what these commands do is basically the first one is to get out from the src as I told, and then colcon build compiles everything in a workspace, creating build, install and log directories. And then when the build is done, we write source install /setup.bash so that it configures our terminal on ROS2 so that it can instantly run and save the new package. Remember, each time you open a new terminal or after rebuilding, you'll need to resource this file. Consider adding it to your .bash rc for automatic sourcing. We can do that by writing echo. I have not included it here, but you can always do that if you want your life simpler. Now is the final part where we see the live ROS2 demo. So for the last part, we'll see ROS2 in action with the classic publisher or subscriber demo. This shows how different robot programs talk to each other. So we start by writing, firstly we open a new terminal because we need two terminals for this, and we write the same code, which is source /opt/ros/humble/setup.bash. you can just copy this line and paste it in the new terminal as it is the exact same as the left one. Then you have to write source tilde slash my underscore new underscore ros2 underscore ws slash install slash setup.bash. Oh, I think I missed something. Oh yeah, I missed the slash after my. So I'll press the upper arrow button and just write the slash, and then I'll just copy this exact same line to the right terminal. You can do this by right clicking, press copy and then press paste. Just simply paste. I don't know why it's not working. Yeah, finally worked. So now we have to simply run two commands. Always start the left one, write ROS2 run demo underscore nodes underscore cpp docker. So basically it starts a node that keep publishing messages to a topic called /chatter, and then you can think of it as robot sender. To the right you have to just write listener instead of talker, and this command starts another node that listens to the same /chatter topic, that is the receiver or subscriber of, and it prints every message it hears. I'll just tell you the final some commands. Just stop it using Control C. Just write ROS topic list, and by pressing enter you'll just get to know the commands of ROS2 topics, and then write ROS2 topic echo /chatter. So it will just provide what is going in or out of /chatter. This is the first demo for you, and you can just close the terminal, and then you can simply safely close Ubuntu because our task is done.